When we first began thinking about this building, we wanted to fit into the City of London and be respectful of its history and character. Our desire to meld into the city is one reason, but not the only one, why I thought that Lord Norman Foster was exactly the right architect for this building to design it and to oversee its construction.
It's all about values. What is appropriate, respectful, fitting in terms of the city. If you think about a 10-story building, in the scale of the city, I could make this building look lower by setting the top 2 stories back, and I can give more dominance to the middle. To recognize that this is a building in a historic city, you can use historic devices. You can express this with a stone structure, and then if you want to protect it from the sun, so you can have these large sculpted fins in bronze, which will age and change gracefully over time. You can see a more precise amplification in the facade here. But that facade is eventually going to come out of real material. Bronze, sandstone, harder, darker stone. Those will be explored in samples, and we can feel them, we can walk on them, we can test them. And then detail models. And then we need some models on site, full size.
The story of the facade of Bloomberg London starts with English sandstone and the only quarry in Europe capable of delivering the 3,000 cubic meters required for the envelope of the building.
This is the largest stone project undertaken in the UK in over 100 years. The brief was that the building was to sit well between St Paul's and St Stephen's Church, and the selection of the stone was an integral part in that process. Only a small percentage of the blocks that come out of the quarry will actually achieve size and colour required by the project.
The selected stone is then cut to size and attached to precast units made of steel and concrete. To ensure a graceful continuity of colour and grain, each section of the 300 stone-clad beams and columns is matched by eye. But the design also requires complex curved stones, and to cut these it is necessary to look abroad.
We have this huge deposit of marble, so most of the economy on this area has been based since centuries in stone.
At Savema, a highly specialist multi-axis wire saw, its cable coated in industrial diamond, cuts the most complex curved stone for the facade. But Savema is renowned not only for its high-spec machinery, each piece of stone is finished by hand by a highly skilled mason.
We hire sons or ex-workers, even grandson of workers, which they feel. They know what it means to work in a stone company. That's what makes the craftsmanship and make the difference between other companies. Machine will not make Bloomberg. Human being and machine will make Bloomberg.
It's in Japan that the most handcrafted element of the facade is worked upon at Kikukawa, where a unique colouring process is applied to the bronze.
150年前にこちらの龍海節という仕上げを開発しました。もともとあったテクニックを創業者の祖父の方が改良しまして、吉川独自の方法でブロンズパネルに色をつけるという仕事をしています。こちらの溶接および仕上げ作業は非常に熟練した職人のスキルが必要になりまして、こちらのセクションでは年長者がリーダーとなりまして全体の指揮を取りながら若年の若いスタッフの指導に当たっています。
Filming this process is strictly prohibited, as it remains a highly confidential trade secret.
No.
bronze fins on the building are really special. We're already seeing the way that they change color as the sun moves across the skyline. Anywhere from a golden hue to a rich brown. When you take truly innovative design, partner it with the finest materials and workmanship, you have the recipe for something really special.
One of the most technically challenging parts of the facade is the serrated glass. These are the largest pieces of grooved glass in the world and could only be manufactured by one company in China.
North Glass is doing special glass sizes and treatment to the glass which not a lot of companies in the world are doing. The serrated glass is very large with 3 meters in height and 3.6 meters in length and weigh up to 900 kilograms per unit.
Glass of this size, profile and depth has never been produced for the exterior of a building. Which is why Gartner, who are responsible for the panels that fit into the stone framework of the building, are keen to thoroughly test the finished product.
Today's test was the impact test on the Type B profile glass facade. Quite an important test because that glass has really never been made to that profile before, so we were uncertain as to the outcome.
With this impact test passed, the engine of a Hercules aeroplane is deployed to check the window panels can withstand perhaps their greatest adversary, the British weather.
Our next stop is Helsinki, Finland, where the engineers at KONE have really outdone themselves creating a first-in-its-class glass lift, which forms an integral part of our facade.
This is so special. We engineered totally bespoke electronic components for this case, and that kind of stuff is never done before. We've got the best engineers and specialists and designers to work for this project.
The biggest technical challenge has been to hide the mechanical elements in the base of the glass units. To ensure the 18 scenic lifts will meet the needs of the building, a lift shaft has been erected in the factory and tests have been carried out to measure noise, vibration and speed. These handcrafted materials, stone, bronze, glass and the innovative scenic lifts come together to create a unique yet classical facade that fits seamlessly into the historical environment.
Well, even the finest materials and workmanship can be blemished by its environment, and one of the worst culprits is birds.
The facade of the Bloomberg building has got lots of angled features which are very attractive to birds. If you get a big build-up of droppings, A, it's very expensive to clean, but more importantly, they're quite corrosive and they can damage the structure over time.
Which is why the architects hired ornithologist Nigel Clark for advice at the design stage to ensure the building was less than ideal for pigeons and gulls.
The Bloomberg building sits in an area of London with lots of historic buildings. They are actually quite attractive to pigeons. So the key is to ensure that it is less attractive than those buildings.
It's a continuous process, toing and froing. It's a conversation, it's an exploration. But the end goal is very finite. It's a building.